Hello and welcome to the next video in the series introducing Hyperflow AI. In this video, we'll build a flow graph that creates a knowledge database about a particular topic that current LLMs know nothing about, and use it to build a chatbot that is an expert on that topic and can help users learn about it. These are so-called domain-specific generative AI apps, and they are one of the most common augmentations of a pre-trained LLM. Rather than do additional training of a model, also known as fine-tuning, which is difficult, time-consuming, and expensive, we will use the well-regarded and economical approach known as RAG or RAG, or Retrieval Augmented Generation. The basic idea is to build a database of knowledge about the domain of interest and retrieve items of knowledge from that knowledge database relevant to the user's query and provide those to the LLM along with the user's query and instructions that it analyze the provided knowledge chunks and generate an answer based on that knowledge. Here's a quick picture introducing the RAG approach. On the left is the knowledge DB building process, which in many cases we just do once. On the right is the typical chatbot loop. See down here, users entering queries, turned into prompts likely containing the conversation history, sent to an LLM, and giving the generated response back to the user, and around we go. What we want to do is take the user's query and look up relevant segments of knowledge and insert them like this into a combined prompt. We'd stick in the conversation history, instructions to use the following knowledge segments to answer the user's query, the retrieve relevant knowledge segments themselves, and then the user's query, and send all that to the LLM. Fortunately, LLMs these days are more than able to follow instructions like this, look at the knowledge segments, decide which are really useful, and compose a useful response based on that knowledge. An important thing to note here is that we should try to control the size of this combined prompt. The larger they are, the more expensive in one way or another. So we want to be clever about what knowledge segments we retrieve and insert into the prompt. Best in small, highly relevant segments, both to minimize costs and to keep the LLM focused on generating a good response. One of the best ways to do this is to use a so-called vector database. This is a relatively new way to store information and look it up by meaning, not just the words it contains. This means the knowledge segments don't have to match the exact word you use in a query, just its meaning, which makes it much more likely to find knowledge segments relative to a query, no matter how it's worded, or even what language it's in. So we are first going to build a flow that performs the task on the left here, reading in knowledge sources. Hyperflow can import from many kinds of sources, segment this knowledge into useful chunks, construct the vector indexes, also called embeddings, and then build a vector database from them to act as our domain knowledge database. Then we'll build a chatbot that can search and use this knowledge DB, and so create our domain-specific app. Okay, we're in the Hyperflow IDE again. So let's build the flow to create the knowledge DB. Oh, first, what's the knowledge domain? Well, how about Hyperflow itself? None of the current LLMs know much about Hyperflow as it is very new. But we do have a beta documentation subsite here, so let's see if we can load that into a knowledge database and build a chatbot that can assist people using Hyperflow. That could be useful. So let's have a quick look at that site. There are some welcome notes, some useful links, a big node reference with detailed pages on every node. Back here, a reference on the currently available service adapters, a section on data types, and finally a detailed spec of the production app control API, which you'd use if you are building your own custom chatbot or AI app client. Looks like a useful source of knowledge for a helper chatbot. Back in the IDE, I think this time, rather than building and wiring the flow graph node by node, which is covered in the building and running flow graphs videos, we'll use a flow from the template library here. This will be populated with a lot more templates in the final release, but for now, it does have a web-based knowledge builder. Let's clone it into our project and give it a name. and a tag. Okay, and here's our new copy. So it's an import node sending imported content to a segmenter node that will break the content into useful chunks. Recall, we want to inject into the combined prompt just the knowledge needed to answer the current query. So breaking it up into the segments allows that. For each segment, we create an embedding vector index so we can find the segments nearest to the meaning of the user's query. And then we use those to build the knowledge DB. You'll see how this gets used later when we build the RAG-based chatbot. Let's step through the nodes, reviewing their parameters. For the importer, the template has several preset parameters, suitable defaults for a web-based build. It's those in gray here. If you hide the locked parameters with this button up here, you can focus on just the parameters the template wants you to provide or to check. But let's unlock them all and see what the options are. First, selecting the importer service. Many of the nodes in Hyperflow make use of so-called services, which are different implementations of the same basic function. These can be added with the plugin SDK, allowing us to continually expand the power of these nodes. Most nodes that use services have a Hyperflow built-in service, and in this case, we've also surfaced some of the LangChain importer modules. We'll add more of these and other importers over time, but the Hyperflow built-in importer is quite powerful, and we'll use that in this case. Okay, the import source is web. We could upload files or make an API call. You should always add a tag or two for the assets imported into or created by Hyperflow nodes. They're all automatically stored in the project's asset library, and the easiest way to find and reuse them is with their tags. We need the URL of the website we are going to import. Let's go back to the doc site and grab the top URL. Okay. The imported website can be stored and passed on in several forms, such as the original HTML or just all the text on a page. I recommend in this case using heading separated text, which works well with one of the built-in segmenters to create segments at heading boundaries in the pages. If we look back at the doc site, we can see that the sections have headings. And this import mode will mark these with a special separator that the segmenter will use so that we can basically get a segment per section, which is an ideal segmentation in this case. Next, most sites these days use dynamic HTML, which runs scripts to build the page directly in the browser. So we have to allow for that and set options that help us wait for this to run in each page so that we can import all the content that we need. And we want to get all of the pages in the doc site. So we choose site crawl, which follows all the links on each page down through the page hierarchy automatically. All the pages should be within 4 links down, and we should get all of the pages. You could limit the import count during initial testing to get faster previews. Now we just want to import the pages in the docs subsite and not to wander off to external sites that might be linked in the docs pages, so we choose subsite only. And these other options allow us to follow script-based links and use additional filters to focus on just the pages we want to import. The content segmenter node has many options with presets in this template to match the heading separator import mode that was preset in the importer node. Unlocking shows the built-in and other segmenting services, including selected components from LangChain and Llama Index. Using the built-in segmenter, we select the type of source content here. There are specialized segmenters for PDFs, HTML from web pages, or text. Since we asked the importer to produce heading-separated text, we should choose text here. The text segmenter has itself several modes, and we should pick separator pattern to make use of the heading-based separators installed by the web importer. The various built-in services cooperate, such as using the same strings for default separators, etc., so we can just use the defaults. The heading separator will automatically add heading context, as you'll see, so we don't need any overlap, which you might otherwise add so the LLM can see some surrounding context for each segment. And tags, always. Now, embedding vectors. We have adapters for the OpenAI and Cohere commercial embedding services and some open source embedding models on the built-in Olama server. The OpenAI large model works very well and it is relatively inexpensive, so let's use that. Pick the large model and max dimensions. We'd perhaps pull back on those with a really big vector database, but the 90 pages or so on the current Hyperflow doc site is relatively small. Embedding vector spaces are really cool, and we have a neat interactive 3D visualizer for them, which I'll show in another video. And finally on to the vector DB creator. It uses the embedding vectors as lookup indexes, and these will be used to find all of the segments that are semantically related to a user's query, as I mentioned earlier. We currently have adapters for 4 knowledge database services, but at beta release, the Pinecone and MongoDB services have some rollout issues, and we'll enable them in an upcoming release. So let's pick the built-in Face Vector DB. It is ideal for the smaller vector DBs, and it works quite well. It supports 2 kinds of indexes, and we'll go into the trade-offs of the options in all the services in the docs and later videos. But for now, just use the defaults we've selected for you. They work well for most cases. Okay, we're ready to run. All right, just a quick check once more and say, okay. We could have locked down all the parameters during setup and it would start importing automatically. There are around 80 pages in the doc subsite, I think, and we've told it to wait for 3 seconds for each page to load to be sure the page has all the content we want. So this is going to take a little while. You can see here the importer is reporting progress. Okay, I'll skip forward in time and you can see we have imported 89 pages and jump to the segmenter. This node will let us preview the segmentation and make parameter adjustments if we want and preview those changes. Let's take a look at the current preview. Okay, this looks pretty good. We do indeed have the sections in the pages as separate knowledge chunks. And you can see here that the importer has included the headings as extra context for each segment. And here we see the segmenter has recorded useful information called metadata about each segment, the web page title, its URL, and so on. This will help us produce more useful responses to a user, adding, say, reference links to the pages containing the knowledge segments that the LLM used for its answer. Okay, let's complete the segmentation. You see it's reporting segmentation progress. Okay, from the 89 pages, we extracted a little over 800 segments. So let's press on and create the embedding vectors for those segments. Each segment is now being passed out to OpenAI, which returns the vector index for each, which Hyperflow stores for you in the project's asset store. We will sometimes run several separate import, segment, and embedding runs for different kinds of sources, and then gather all the embeddings from each run to make a single final knowledge vector DB. Okay, we're now ready to build the knowledge DB. Click OK. And it's loading the vectors, building the DB. And we're done. Okay, we now have our embedding vector-based knowledge database. Now we need a RAG-based chatbot to use this knowledge DB to help new Hyperflow users. Okay, I'm going to use a shortcut here to drop in a ready-made RAG chatbot component using our snippets library. In the editor, bring up the context menu and choose snippets and select RAG-based chatbot, and a copy will be inserted. We will be providing a large selection of useful flow graph segments in the final release snippets library. Okay, this looks like a regular Hyperflow looping chatbot with the addition of a search knowledge DB node in here. We pass the user's query into both the call LLM and the search knowledge DB, and the relevant knowledge segments retrieved go into the knowledge input connector on the LLM call node. All we need to do is configure this to use the vector DB we just created, bring up its parameters, and click that DB in the selector. The other parameters there determine how many knowledge segments with related meaning should be retrieved and given to the LLM. Let's start with a healthy 20, and we can tune that down as we see how well the retrieval and LLM work together. Leave the probe number at default. It tells the search how many neighborhoods in the vector space near the query it should search. We also need some instructions to tell the LLM its role and to ask it to use the retrieve knowledge segments. So let's start with something simple. How about this? You are an assistant helping new users learn how to use the Hyperflow flow graph-based development environment for building RAG-based and agentic generative AI applications. You should use the knowledge segments supplied to help answer any user questions. Okay, this can be expanded a lot with very specific and detailed instructions, which will often help substantially. We might look at that later in the video. And of course, this is where the art and science of prompt engineering has such an impact. And we'll have more to say about it in upcoming docs and videos. But something like this will do for our initial tests. Let's see the call LLM parameters while we're here. Leave it in chat mode for the initial tests, and let's use trusty GPT-4o from OpenAI. Hang on, we now have two flows in the editor. This is actually quite common as you are working up a more complex application, constructing sections of the final app that you try out, eventually wiring it all up in a final graph. You just keep setting the start node in the fragment you're working on. In this case, it's not uncommon to keep the knowledge DB builder in the same graph as the final chatbot that's using it. Let's set the start node here and give it a run. Okay, what would be an interesting query? Okay, how do I wire up several nodes' outputs to a single input? Hyperflow won't let me do that now. Okay, you can see it's off searching now. And there you go, then it's retrieved 20 segments. And they hand it off to GPT-4o. And here comes back the response. Oh, okay, that is spot on. Wow, this works well. Go RAG-based chatbots. That's exactly what I would have recommended. It's picked the right nodes and explained what's going on. Wow. Let's look at the run log a bit. We can see up here the knowledge DB search results. And because we used a vector DB, the results include a ranking, which is the distance between the query vector and the segments vector in the vector space. When you ask for the top 20 or the top 10 or whatever, the selection is based on this ranking. Each knowledge segment also has some metadata, including the website page title and URL that the segment is saved for us. Hyperflow knows how to format metadata like this as useful references in a query result. But we have to instruct the LLM to identify the knowledge segments it's used and output them in a special format that the call LLM node knows. Okay, so let's do that. Let's look at the instructions again. Now, I'm going to post in an upgraded set of instructions that I worked on before. And these include the request to report the knowledge segments used in a special format. That's one of the reasons there's a segment number at the front. The search node added that for us, and Hyperflow uses it to find the associated metadata and display it as references. Okay, let's try some more queries and see if it works. Is there a way to update a vector DB with new content? Oh, and yes, it's suggested that we use the real-time knowledge injection node. Exactly the right one to suggest. That's what this node is for. More importantly, Hyperflow has recognized the reference data here we asked the LLM to output, and it has used the URLs in the segment metadata to add reference links. And if I click on one, it should take us to the relevant page. Oh, cool. Perhaps one more. I want to implement a long-term store for the conversations between a user and an LLM. And again, the retrieved knowledge was useful, and the LLM gave a correct answer, recommending the use of the key value store node, perhaps in tandem with some other tool nodes, and has provided the right links down here. Well, I think that's a very satisfactory demonstration of the power of RAG-based approaches. Very economical compared to fine-tuning, which would be quite time-consuming and costly. It also demonstrates the leverage Hyperflow can bring, developing such AI apps with a minimum of effort. In fact, this looks so promising. I think we'll polish it up a bit and add it to the Hyperflow help system for you all to use. Keep an eye out for it. Don't forget to check out the other videos in this series, and thanks for watching.